Good day everybody and welcome once again to chemistry tutorials with Tutor Taye Emmanuel Oyedun. And we are going to be solving this question today. This is a calculation question under the topic electrolysis. So let's read the question together. Calculate the volume of chlorine gas produced during the electrolysis of fused potassium chloride if 7.8 grams of potassium was deposited at the cathode in the same experiment. And of course, we have the following constants that would be helpful for us in order to solve this particular question. Okay, so let's bring out the parameters for the question. The mass of potassium that was deposited during this particular experiment is 7.8 grams. 7.8 grams. So the molar mass of potassium is 39. Of course, the charge on potassium has the charge K plus, isn't it? That means the charge on it is going to be 1. Okay? So the quantity of electricity supplied, which is also IT, that is current multiplied by time, is not given in this question. We don't have any information about the current, we don't have any information about the time, neither the quantity was given. Mind you, what we are looking for is the volume of chlorine, but we need to get this quantity first. So we are going to know the quantity involved in this experiment that would produce the volume we are to calculate. Follow me on carefully. Okay, so 1 farad, of course, is given as 96,500 is a constant coulombs. And then, remember this formula. This will make us to get the quantity of electricity that was used. So I have 7.8 grams over 39 is equals to the quantity of electricity we are looking for. Charge multiplied by 96,500. So if you are looking for the quantity here, Q will be equals to, by the time you cross multiply, you are going to have 39 times Q. Let's cross multiply first. Q times 39 is equals to 7.8 multiplied by 1 multiplied by 96,500. So you divide both sides by the what? Coefficient of Q. So Q here will now be what? If you press this on your calculator, this is pressed on your calculator, you are going to have 7.8 multiplied by 1 multiplied by 96,500 divided by 39. That gives 19,300 coulombs. 19,300 coulombs. In other words, this is the quantity of electricity that was used during this experiment. But that is not what we are told to calculate. However, you need to calculate this before you can get the volume of chlorine that was deposited, that was produced during this experiment. So now, normally in this kind of experiment, since one charge is involved, it means one electron is also being involved in the process. Which means 1 farad, because it's one charge, the charge here is 1. So it therefore means that 1 farad would deposit 1 mole of chlorine gas. Right? So 1 farad is what? 96,500 coulombs of electricity would be the one that would deposit 22.4 dm cube volume of chlorine gas. Now, what volume will now be deposited if 19,300 coulombs was used? Call that X or any letter that you best prefer. So I can cross multiply so I can get X now. So X will be equal to 19,300 multiplied by 22.4 divided by 96,500. Okay, from here I want to cross multiply to get to this particular point. In other words, what the question means is 19,300 coulombs of electricity was used. So what volume will be produced? If 96,500 was used, it will have produced 22.4 dm cube. Since this is not used and this was what was used, what volume will be produced? So you can press that on the calculator. 19,300 multiplied by 22.4 press equal to, divide by 96,500. That will give you 4.48 dm cube. So the answer here will be 4.48 dm cube. I believe this video helped somebody, or has helped you rather, to learn more on how to calculate problems that relates to electrolysis. So kindly subscribe to my channel or follow this page as the case may be, in order to get notification for next videos on chemistry tutorials. You can as well send in any question that you feel is challenging you in chemistry, and as a comment, or you can send it to my as a direct DM, or you can comment with it in any of the posts that you see on this particular page. So thank you very much for your time. See you in the next video.